This is the Sencore PA81 Power Amplifier Analyzer, Stereo Power Amplifier Analyzer. You've probably seen it in a few of my earlier videos as well. Basically what it does is provide a dummy load for each channel, the left channel and the right channel, and you can sort of divide this down the middle. The controls to the right are generally for the right channel and to the left are for the left channel. The difference is that these two switches are actually function switches, so they affect both channels. So you apply your signal here from the speakers. You connect these to the speakers, and then you can switch the load with that switch. As you see, you can go from 2 ohms, 4 ohms, 8 ohms, 16 ohms, or 32 ohms, or an open. And it has an overtemp sensor if you have overheated the power resistors that are inside, the dummy loads. It also has a DC balance check. What it's doing there is it's trying to trip if there's more than a volt of DC output on any of the either of the speakers, and it will show you which one. This is especially useful and helpful when you're doing intermittent testing, because you can leave this connected, and when it trips you can then come and look and see whether it was the left channel or right channel that tripped. This is the store button. You can program this when the meter is over in this blue region to store a particular dB level and then use that as the reference instead of using 0 dB. It's very useful for doing gain measurements in stages. It has basically three functions that affect the meters. All of these, which are watts, RMS volts, dBm, and dB programmable, work off of the speaker. The top works off of the external input. That is, it's used for like a tuner or a preamp input. And similarly for the blue side, they work. Let's take a look down here and you can see this is the external input, and you see it's color-coded blue. It works with this side of the meter. They're basically the same functions for all. And then the yellow is the line in. That's just a regular RCA jack. For example, from if you wanted to check the output of a tuner, the line output of a tuner, you could plug it in here, and then you would use the yellow part of the meter. The meters are auto-ranging, and they basically indicate or read in RMS volts or in dB. And they switch over about, I think it's 6 ranges. So it goes all the way up to by 100 and all the way down to by 0.001. So let me switch this on, and you'll see it goes through a little cycle there, and you may have heard the fan come on briefly. The fan is what cools those power resistors. So before I hook this up and start using it with an amplifier, I thought it might be instructive to open it up and take a look at the power resistors inside, because that's one of the impressive features of this particular instrument. It's not the only dummy load that has big power resistors, but that's one of its main features. So let's do that. I've pulled out the PA81 to show you the power resistors inside. To get to those, you have to remove the panels here. In order to do that, you have to remove these bezels. There are 3 screws on top, 3 on the bottom, and then there are these little side feet that you have to remove. So a total of 2 on each side, 3 on the top and bottom to get one bezel off. Then you have to at least loosen the other bezel so that you can pull the panel out from under it. And then you can remove the top and bottom panels. So let me do that. These are the 250 watt resistors in the PA81 that are used as dummy loads. There are different sizes, and different ones are switched in depending on the front panel setting. And when I say 250 watts, that's 250 watts intermittent, in other words peak. it will take 100 watts continuous as long as the fan that you see back there is running. So this is one of the features of the PA81 that makes it especially nice for amplifier testing, because you can test amplifiers up to about 250 watts, at least intermittently, and continuously up to 100 watts per channel. And here it is from the back of the fan with the shield put back in place over those resistors. That helps to direct airflow over them so they stay cooler. Now I've reassembled the PA81, and I've got the ohm meter connected to the left channel input, dummy load input, and what I'm doing is I'm checking the resistance. This is the 8 ohm position, that's the 4 ohm position, the 2 ohm position. Let me check 16 ohms. Well, that's 32 ohms, I'm sorry. 16 ohms. And then we'll set it back to 8. And then I'll do the same thing on the other channel, just to make sure that the dummy loads are still properly connected and I didn't leave a connector off or something like that. So now we can get back to using this unit to test amplifiers. I've now connected the PA81 through those terminals that you see there, yellow for left channel, red for right channel, to the speaker outputs. I am using the CD input of this Sony home theater receiver that I've used before and some others. I'm not going to be doing a review of that, although it has been a pretty good unit. I like it. The thing I like the most about it is it has a 4-input HDMI switch that works with all of the formats, ultra high def, in other words the new 4K standard, as well as 3D and all the old HDMI standards. Seems to work really well. So it's a good enough amplifier and tuner and so on, but there are lots of those. But the one feature I like the most about this one is that the HDMI switching really does work. But this is not about home theaters. This is about amplifier testing. So I am hooked up to the Analog Discovery 2. You see the cables coming out there. That's a splitter that splits the output from the wave gen into 2 channels. So I'm driving the left and right channel with the same signal. Over here is the wave gen on the screen, and it's a 1 kilohertz 50 millivolt 500 millivolt signal. In other words, it's about half of the normal line output. And let's go over and look now at the PA81. You see the signals being displayed here, and it's about 5 watts being shown. What I'm going to do is turn up and you'll notice that the meters are showing exactly the same level. I'm going to just zero in on 1 meter now. And you see we're reading about 5 watts. I'm going to be turning the volume up. We're up to about 10 watts, 15, 20, 25 watts. And the reason that the volume went down is you notice that the auto scale switched. And now it's multiplying by 10. So that is about 20 watts. We'll keep on turning this up. We should get about 50 watts or 45 watts with half input, and we get about 30 watts. Let me turn this back down. And by the way, the signal that you're hearing is because I have the speakers turned on in the PA81. This allows you to monitor the signal. What I'm now going to do is raise the input level to the full 1 volt spec. That's now with a full 1 volt in, and you notice that the power jumped up. Now I'm going to turn the volume up. We've switched. We're now on the second output, and we should be able to get about 120 watts out, and that's, we're getting about 130 watts with the volume at max. So that is an illustration of how the PA81 works. And what I'm going to do is try to wrap up a little bit of this segment and then come back for one last look at the PA81 by talking a little bit about these filters. Now you may notice that they say IHF input filters, and actually what those are, let me turn the power on down here, no point in salting our ears or heating up those dummy loads for nothing. IHF, of course, stands for Institute of High Fidelity. It's a now defunct organization, but they put out a series of standards. And before I talk about these filters, because they can be quite useful in measuring amplifiers, I think it might be a good idea to review a little bit of that history. When people began trying to produce high fidelity sound in the years after World War II, one of the things that they realized were that there are many factors that affect our perception of music. And I have listed the ones that the researchers found in order of their importance. The most important factor, frankly, in music perception is the individual. Music is very complicated, and we'll look at a little bit of the characteristics of instruments in a second. In fact, it might be a good idea if I did a little video on those factors, the instruments and their influence on music. But let's just regard music as a generality here. The most important thing that people who have studied music have found is that personality affects the perception of music a lot more than we like to think. In general, we all are both subjective and objective personalities, but what we mean here, or what the researchers were talking about, is people who tend to see things subjectively. Generally, the subjective part of our personality, and by the way, about 2/3 of the general population have more subjective than objective personalities. In other words, they tend to see things more subjectively rather than objectively. These people, that is, those with a more subjective personality, tend to go into fields like marketing and public relations, politics, things where they're dealing with people. Objective personalities, and once again, as I say, everybody has all of these factors, it's just a question of weight. A person who tends to be more objective and represents about 1/3 of the general population, they generally tend to see things in terms of numbers. And they tend to be engineers and doctors and scientists and people like that. The reason that's important is that when they first tried to do studies, listening studies with individuals, what they found were that the subjective personalities needed to know what they were listening to before they could make judgments, before they were willing to commit to something as being better or worse. Objective personalities, on the other hand, needed numbers. So if you told a subjective personality that this is a 100-watt amplifier, that wouldn't make as much difference as if you said this is a Macintosh amplifier. And if they knew about Macintosh, they would say, oh, okay, so it's a good amplifier. If you told the same thing to an engineer, the engineer would pay attention to the 100 watts and not to the fact that it was a Macintosh. And this really complicates the study of listening in music. Another factor that influences it is the sheer ability of people to hear as well as their experience. And you might suspect that people with a lot of experience in music would actually have the better perception, but it turns out many of them do not. I won't go into the story, but there's a famous story on the BBC where Sir Thomas Beecham, basically a very famous conductor and music expert from the 1960s, was completely unable to detect distortion in a variety of different contexts. So experience doesn't necessarily mean that you're a better listener. Obviously, taste matters. And the reason that matters is undistorted sound is more pleasant to some people, whereas distorted sound is more pleasant to others. Take the case of hi-fi versus guitar amps. Most guitar amps deliberately distort the signal. There also is a difference between Western and Eastern music in terms of what people perceive as distorted. In Eastern music, odd harmonics are not considered necessarily bad distortion. In Western music, even harmonics are considered not bad. So your taste in music affects what you hear as well. The next most important area are the speakers and the enclosures therein, and that includes the room that you're listening to, that is the acoustics. The next most important was the source, mechanical versus magnetic versus optical. Of course, in the early days, mechanical was the only way, LP records, for example. Later, tape came along with magnetic characteristics, and today there are a lot of optical. For example, DVDs and CDs and so on are all optical systems. That affects the quality of the music, or maybe I should say is a factor in the perception of music. I have defined here as the original versus compressed or compacted. And what we're talking about here is a lot of music today is encoded in a compaction format like MP3 or MP2 in the case of early DVDs and so on. The next area that most researchers found was important was the preamplifier, how the tone controls are set and how the equalization was done. Now, equalization is an attempt to make up in some measure for the original source. So, for example, a record player, an LP record on a turntable and a tone arm would have an equalizer that would attempt to correct for the changes in the characteristics. And finally, at the very bottom is the power amplifier. And I go through all of this because, in general, research has shown over and over and over again that the one thing that affects people's music perception the least when you really do a double-blind study is the power amplifier. And yet, it's the thing that is almost always overemphasized in purchasing hi-fi equipment or whatever. So let's take a quick look at some musical instruments and then talk about the actual way that people have tried to test amplifiers over the years. Here is a chart of a large number of musical instruments, including a male and female voice at the top, things like a bass clarinet, and so on. And you may notice that many of these instruments don't go very much below about 500 hertz. This is 1,000 hertz. This is 500, about where the left edge of this printing is. And you notice that things like a glockenspiel, a piccolo, even a tambourine, a triangle, they don't go much below about 500 hertz. However, a lot of musical instruments go considerably above 15,000 hertz. Why does that matter? Well, it turns out the human ear is not generally very good above 15,000 hertz. In fact, as you get older, as you probably know, it actually gets worse. Another factor that is affecting a lot of young people today is if you listen to a lot of loud music, like with loud headphones, your high-frequency perception or ability to detect high frequencies declines. And the studies vary, but in general it looks like it's a fairly permanent decline. So if you listen to a lot of loud music using headphones especially, you may find that it doesn't really matter what your amplifier does in the high end because you can't hear it anyway. Okay, so having seen all of this, what was it that led to the Institute of High Fidelity being formed, and what is it that they did? I'm focused in this video on power amplifier testing, so I'm going to restrict this history to that. And I point out at the beginning that there always has been a distinction between consumer equipment and professional equipment. Professional equipment is the sort of thing that might be used in a recording studio or things of that sort. I'm limiting here to consumer equipment. And one reason that that's important is professional equipment actually uses a whole different set of standards. In the U.S., in the 1960s, a group called the Institute for High Fidelity began releasing amplifier specifications, or rules, if you will, for testing amplifiers. The first one of much note was called the A200. It was followed by the 201 and the 202. And those specs lasted from about 1966 to about 1981. In about 74, the Federal Trade Commission came in and issued a set of rules published in the Federal Register that regulated how you could advertise power amplifiers. And before that, it was all over the map. Even since then, creative marketeers, remember those are the subjective people, have found ways to use numbers that defy science, is, I guess, the best way I could put it. The Electronic Industries Association issued a radio standard 490 in 1981 that effectively replaced the IHF standard, and that lasted up into the beginning of the current century. It was then turned over to the Consumer Standards Association, who upgraded that to 490A and issued a revision of that. The last revision that I have a copy of was in 2008. And then there also is the Society of Motion Picture and Television Engineers. They have their own set of standards. The Europeans, on the other hand, have the AES and DIN. This is the European Standards Association, effectively, and DIN is actually a German Deutsche Institut Normung, which Normung means standard, so it's basically the German Standards Institute. They have their own standards. The reason I point all that out is that all of these have attempted to show what the power of an amplifier can be in terms of a power amplifier. The trouble is that you can define power in terms of peak power, continuous power, or in terms of dynamic music power. And I won't get into all of those differences. What I tend to do is use continuous power, which is basically you measure the RMS voltage across a known load, you square the voltage, divide by the load resistance, and that is your continuous power. Some people call that RMS power, but it's really not RMS power. RMS is a voltage, but nonetheless, it is a continuous power measurement. The next thing you do is you measure distortion, total harmonic distortion, intermodulation distortion, and others. These are the two that are generally most used. You also measure the response, and that can be done in terms of steady-state sine waves, which is called frequency response, or in terms of transients, like square waves. Also measuring hum, noise, and I put CD in there because the 44 kilohertz CD signal can come into amplifiers and cause distortion. You can't hear the 44 kilohertz, but what it's doing is it's driving the amplifier above and below its linear regions and causing nonlinearities that lead to distortion. Also, there are other things like RF susceptibility and the radiation. In other words, one unit may be radiating RF and the other one may be picking it up, and that may be getting into the signal. And then there are various safety and other regulations. What I'm going to do now is look at the Sencore PA81 in terms of continuous power and in terms of being able to restrict the frequency response in a way that you can test for things like hum and noise, as well as CD noise and things of that sort. So let's go back and take a look at the front panel of the PA81 again. Here is the front panel once again of the PA81. Now let's zoom in a little bit on this IHF input filter section and talk about that, because that is the section where I find the PA81 to be most useful. Now, it's also quite useful in the fact that it has nice dummy loads. These filters were originally specified by the Institute of High Fidelity. Obviously none means that you're just testing the output of the amplifier without any kind of filtering. The bandpass filter is a 20 hertz to 15 kilohertz bandpass. And if you remember when we looked at music, very few instruments actually produce usable sounds above 15 kilohertz. So the IHF originally had their bandpass cut off at 15 kilohertz. The next is the high pass, where it basically passes everything above 20 hertz. Let me show you that in the PA81 manual. At the top is a depiction of the bandpass characteristics. The high-pass filter passes everything above 200 hertz. So it will include, for some amplifiers, frequencies out in the hundreds of kilohertz. It also has a low-pass filter which cuts off at 15 kilohertz. It will pass very low frequencies, but it will cut off the high frequencies at 15 kilohertz, which is about the limit of most people's hearing. Then there is a 38 kilohertz low-pass filter, and that is intended to be used to filter out CD noise. CD is around 44 megahertz or 44 kilohertz, and as a result, if you cut off at about 38 kilohertz, you cut off the CD noise. These can be used for various measurements of hum and noise and so on that I won't go into. You can download the PA81 manual. I think it's available on online. At any rate, I'm not here going to be trying to do a video on PA81 operation, more just on its capabilities. So let's take one last look now at the PA81. So by setting these IHF filters to various positions, you can determine, for example, what the overall bandpass characteristics, that is the normal range of human hearing. You can test for hum and noise using a low-pass filter that passes the low frequencies like 60 and 120 cycle. You can also cut off with the higher low-pass filter. You can cut off CD noise. All of these can be useful. You can also test stereo separation by putting a signal into one channel and shorting the other channel and looking at how much one channel affects the other channel. But at this point, I'm going to wrap up the video on the PA81. I'd like to move on to some other kinds of testing, but I hope that I've been able here to give you some idea of what the PA81 does. Not because I'm advocating that you go out and buy one of these. They've actually been out of production for some time, as I understand it. But to give you more of an idea of what you might want to look for when setting up a bench to test power amplifiers. But I'll close by reminding you that, as I said earlier, what you will find is while people tend to focus heavily on their power amplifier when making purchase decisions, in terms of the overall music experience, it probably has the least impact on what they actually hear or think they're hearing. I hope this has been useful to you. If so, then I've accomplished my original task. And In any case, I hope to be able to do some more videos on audio testing and amplifier testing. But in the meantime, have a nice day.